Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 31, Acids of Bases, Part 5. Here are our objectives for today's video. Pause here. I'm going to wait about 5 seconds, and then I will say the answer out loud. I expect for this to be neutral. So sodium, it comes from sodium hydroxide. But the fact that sodium in and of itself is always dissociated, it doesn't really react under any circumstances. You can assume that any group 1 metal is going to be completely neutral. When it's an ion, when something is a metal, it's a whole different story. But you can assume that this is ionic sodium. Chlorine, or chloride in this case, is the conjugate base of HCl, which is a strong acid. The conjugate bases of strong acids are completely neutral, so this will be neutral. Pause here. I'm going to wait a couple seconds and say the answer out loud. I expect for this to be weakly basic. So we already know that sodium is not going to be affecting the pH of this particular solution. But fluorine, this is the conjugate base. Fluoride is the conjugate base of hydrofluoric acid. That is a weak acid. The conjugate bases of weak acids are themselves weak bases. So I expect NaF to be weakly basic. Pause here. Right. So when you're looking at structures of things, that you can assume that the strength of an acid is determined by the stability of its conjugate base. So if I have a really stable conjugate base, then my acid will be stronger. So for example, I have sulfuric acid. The conjugate base of sulfuric acid, HSO3-, that not only distributes out the negative charge over multiple resonance structures, it's also distributing out double bonds over multiple resonance structures. So HSO3- is very, very, very stable, hence H2SO4 being a strong acid. Pause here. Okay, I'm going to assume that you can draw the Lewis structures. We can go over it if you need to. But the reason why there is a difference in acid strength has to do with the fact that ClO2- has more Lewis structures, or more resonance structures rather, than ClO-. Therefore, ClO2- is more stable than ClO-, and HClO2 will be the stronger acid than HClO. Okay, here are the practice problems for today's video. Thank you so much for watching and have a great night.